All right, guys, what's going on? Circles Review 2. All right, as Violet says, smash that subscribe button if you want to get updated with the latest videos. Uh, I don't know what's going on. Okay, so equations of a circle. Remember, the equation of a circle starts out with x minus a squared plus y minus b squared equals r squared. Um, when you're looking at the equation of the circle, you're going to tell it's a line, right? Y equals mx plus b. There's no square terms. Y equals like ax squared plus bx plus c. Here x is squared. In this equation, these are both squared. So that's the tip off that what you're looking at is an equation of a circle. They have x and y squared. Okay. When you're looking at the equation, okay, keep in mind that the two numbers inside the circle. Now, if you remember, our formula was actually x minus h squared. So plus y minus k squared equals r squared. So switch out x or h and k for a and b here, and we have the notes that we used in class. Okay, just a different notation depending on where you want to look. But this is what we're talking about: x minus h squared, y minus k squared. So remember, when you take the numbers from the equation and write the center, change the signs, and square root the radius. So circle O represented by the equation. So change the signs. This is going to be -3, +5, and the radius is going to be the square root of 48. Now remember, if you can have your calculator, you can do menu 2, 3. It's going to be your prime factors. If you don't, you can do a factor tree. So 2 and 24, 2 and 12, 2 and 6, 2 and 3. We have 1, 2, 3, 4 2s and a 3. So this is equal to 4 2s and a 3. On your calculator, it's going to be 2 to the 4th times 3. So we circle our sets of 2s, and we end up with 4 radical 3. The two set of 2s, 1, 2 of each comes out, and so we know it's -3, 5, and then 4 radical 3. Keep in mind, you can type this in the calculator, type that in the calculator, and you'll get the same decimals, so you can kind of match them up that way as well. Okay, so here we go. We have a center and the radius. Remember, it's x minus h squared plus y minus k squared is equal to r squared. So we're just going to plug in. Change the sign, so it's x minus 5 squared. Change the sign, y plus 2 squared is equal to r squared. So that's going to be 9. All right, as soon as you see it's x minus 5, you should be able to get rid of like the two answers here. Okay, plus 2. All right, and then we got to get 9, so it's got to be squared. All right, center radius for a circle, change the sign so they're both positive, right? Positive, positive, so these two are out, right? And then the square root. So it's going to be choice 3. What is the equation of a circle whose center is 4 units above the origin? Remember, the origin is 0, 0, so 4 units above means it's going to be 0, 4, right? Y coordinate's 4. And whose radius is equal to 6. So plug in x minus 0 squared, which is really just x squared, okay, plus y minus 4 squared is equal to 6 squared. This is going to stay the same, and this is going to turn into 36. So x squared, there's a y minus 4 squared, there's a 36. All right. Write in the equation of a circle given the center and a point. So if we have the center and a point, we just did it. You're just going to plug it in and get your equation and just kind of simplify everything out. All right. If we have given the endpoints of the diameter, let's go over this one again. Center and a point, okay, on the circle. So if you have that, use the center, right, and find the radius by getting either the distance between these 2 points or plugging into the equation the center and the point and solving for the radius, okay? Finding an equation of a circle given the endpoints of the diameter. Endpoints of the diameter means 2 things. Number 1, we need to figure out the point in the middle. That's going to be the midpoint, okay? And then we need to do the distance from the midpoint to the point on the circle, and that's going to be the radius. If you do all the way across, remember to cut the distance in half to get the radius, okay? So given the circle and the point in the circle, we have the center. We just need to do the distance here, and that'll equal the radius, okay? So let's hop down to this question. Which equation represents a circle whose center is -5, 3, and passes through the point -1, 3? So all we need to do is the distance between these 2 points for the radius, because we already have the center, right? And so you can even kind of go through, and actually I don't even have to do that much work for this, because if the center is -5, 3, my equation should be, change the signs, x plus 5 squared plus y minus 3 squared is equal to something squared, okay? There's only one equation that actually has an x plus 5 squared. So I know it's got to be choice 3. So I can kind of use that process of elimination here to help me out. However, just review the distance formula, okay? It's x2 minus x1, that whole thing, the whole quantity squared, plus y2 minus y1, quantity squared. All right? And then we're going to pick it. So x2, -5 minus -1 squared plus, and then we have 3 minus 3 squared. So this just comes out to be -4 squared plus 0 squared. Remember, negative squared is always positive. Don't put that -16 in here. Don't bring that in the house, okay? So this is equal to positive 16, which means this is 4. And that's going to be the 4 squared, or 16. Okay, here's the endpoints. So the first thing we need to do is figure out the midpoint. Now, if the y-coordinates are the same, right, then just find the middle of the x's, and you're good to go. We can still use our midpoint formula, though, okay? x2 plus x1 over 2, y2 plus y1 over 2, so that's 3 plus 3 over 2. I actually wrote y there, sorry. So this is going to be 4 over 2, and this is going to be 6 over 2. So this is just going to stay as 3. So this is the point 2, 3. That's our midpoint. Now, because it's 2, 3, we know the equation is going to start out with x minus 2 squared, y minus 3 squared. So we can eliminate these two guys. So the question is the radius going to be 4 squared or 2 squared, right? So we're going to take this point, and we'll pick one of these two, and we can just do the distance between them. Now you can obviously just count from -2 to 2, since the 3's are the same, we can just figure out the distance. If you plug it in though, right, so it's 2 minus -2 squared plus 3 minus 3 squared, and you'll see that this is going to come out to 4 squared, 0 squared, this is the square root of 16, so this is 4. So this is going to be 4 squared, and that's where the 16 comes from. All right, on to page 2. All right, equation of the circle is given with diagram. So once again, find the center, change the signs, +2, -4, square root this guy, the radius is 2. So it's got to be a center 2, 4, so, or 2, -4, that's this one, right? That one's out, and that one's out, okay? And then the radius should be 4, so you can count that one's 2, that one's 4. There's my choice. Which graph below shows the center, the circle? So just find the center first, and then I'd use it to get the equation. So -5, 1, and then the radius you can count is just 3. So it's x plus 5 squared, that's one of these two, plus y minus 1 squared, okay, is equal to 3 squared, or 9, and now we got choice 2. Number 1, same thing. Here we just want to count and figure out the radius. So you can either use Pythagorean Theorem, right? You can count, this is 3, this is 1, 2, 3, 4, and I can do 3 squared plus 4 squared is equal to c squared, which is really what this is, and this is going to equal 25, so I know that 5 is equal to the radius. Or I can use the distance formula, right? Now the center is the point -1, 3, so we know it's going to be, change the signs, and then that squared, okay? And there's only one x plus 1 squared, so we got it. All right, set of axes below. Determine the simple triangle form the length between the segment, the endpoints of the circles. Okay, so what's the length of the line segment with endpoints at the centers? So take the first equation. The center is the point, change the signs, -4, 2. The radius is 4. Here we got this guy. Now, because there's nothing attached to the x squared, this is really x minus 0 squared, right? So the center is the point 0, 0, and the radius here is 3. So I go 1, 2, 3, 4, up 2. I go 4 to the right, 4 up, 4 left, left, 4 down, and I draw my circle. Now remember, it's a sketch. We don't technically need to draw the best looking circle ever, although it would be great. And the next one is at 0, 0, and we're going up 3, right 3, down 3, left 3. Okay, thrown here. All right, and then all we have to do now is essentially just figure out the distance between the centers, right? So if you want to, we're going to go over and then up to get there. We're going over 1, 2, 3, 4, and up 2. So we can either use Pythagorean Theorem, or I can use the distance formula. So since you guys are pretty good with the Pythagorean Theorem, so let's just do distance. So square root, okay? The first center is -4, 2. So this is -4 squared. Let's try this again. -4 minus 0 squared plus 2 minus 0 squared. And this is just going to be the same thing, right? -4 squared plus 2 squared. And so this is 16 plus 2. This is square root of 20. And I got to break that down. So it's 2 and 10, 2 and 5. So this is just a square root of 2, 2 and a 5. Pull out my 2's, and then I put 2 radical 5 as my final answer. Okay? Does the point lie in the circle? Just plug it in. That's it. Easy enough, right? Or can you figure out the distance between those 2 points and identify if it's 4? All right? So take a look at the first one here. We want to just substitute it in. We know the equation is, we can, once again, change the signs, right? Plus 2 squared is equal to 16. And if I just plug in for x, this is 3.4 minus 1 squared plus 1.2 plus 2 squared is equal to 16. This is going to be 2.4 squared plus, and this is 3.2 squared is equal to 16. Now, on your calculator, just type this in, right? 2.4 squared plus 3.2 squared, it is indeed 16. So it checks out. So we just say yes, it's on the circle, okay? It doesn't say that we need to explain, so just saying yes with the work is okay. All right, on the next guy, we have these 2 points A and B. The center of our circle, it says, is 2 units from from the midpoint of AB. Now we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5 is the midpoint, and it's just 2 units away. So if we move 2 units over here, there's our circle, okay? You also could go 2 units to the other side. So you've got a couple options here, okay? But we'll pick this point. So this point is the point 1, -2, and it has to go through point A. So this distance right here is the radius. So if we can count this out, we can use Pythagorean Theorem. We know that that's 5 already, and that's 2. So remember, a squared plus b squared equals c squared, or in this case, r squared, right, because it's the radius squared. So it's just 2 squared plus 5 squared, and this is the square root of 29. And so now I know that the center is the point 1, -2. The radius is square root of 29, and now I can state the equation of the circle. Okay? That's it. So I don't think this actually has a question on it, but it should say what's the equation, so we'll put it down. It's x minus 1 squared plus y plus 2 squared is equal to 29. All right. On to page 3. Writing the equation of the circle by factoring using completing the square. So remember, you get an equation that has our circle, both as x's and y's are squared. It's written in standard form, not in center form. We need to complete the square. So process is going to be, number 1, get all the stuff with x's and y's on one side, all the numbers on the other. Number 2, rearrange so the letters with x's are next to each other and y's are next to each other. And then the third thing we're going to do is complete the square. So add the b over 2 squared to both sides. And then we're going to write this in factored form, okay? Now notice, after I add it to both sides, I rewrite the statement here, okay? And then I'm just going to write it as a perfect square, and I'll have my answer. And that's it. So let's take a look at Kevin's work below. Kevin's work, this is one of your quiz questions. All right, we got x squared plus y plus 4x is equal to negative y squared minus 20. So the first thing he did was distribute the negative 1, which is fine. He then completed the square on this side. And so what he did was, if you do b over 2 squared, you would add 4 to both sides. If you notice, he added negative 4, not positive 4 to both sides, right? So we just want to be careful there. So step 2 is going to be our answer. And we would pick that guy. All right, so let's do a couple of these. Got the first one. Equation of the circle is x squared plus y squared plus 6y is equal to 7. Now notice this already is a perfect square. There's nothing else to go with it, so we don't have to touch the x. It's good to go. We do need to mess with this though, okay? So we have first step, everything, all the variables are already on one side, which is great. The x's and y's are with each other, which is great. So now I can just do the b over 2 squared. So 6 over 2 squared is really 3 squared, which is 9. So I'm going to add 9 to both sides. So it's just x squared, which is already done, plus y squared plus 6y plus 9 is equal to 16. And now I can do my factored form. Now remember, this number that we got before we squared it is what's going to go in the parentheses here. Okay? And there's my circle. So the center, right, remember this is actually x minus 0 squared, is the point 0, change the signs, negative 3, and the radius is the square root, so it's 4. So it's either one of these two, it's not that one, it's 16, and we're good to go. All right. And, in case you're wondering, go Celtics. All right. On the next one here, we have x squared plus 4x. So what we're going to do one time is group the x's and y's together. We're going to move this 12 to the other side. So as we bring this down, it's going to be x squared plus 4x plus y squared minus 6y is equal to 12. Now we're going to complete the square. So it's 4 over 2 squared, which is 4, right? And then negative 6 over 2 squared, which is negative 3 squared, which is 9. So this is really 2 squared, right, which is 4. So we're going to add 4 and 9 to both sides, which is really adding 13 here, right? So this is x squared plus 4x plus 4 plus y squared minus 6y plus 9 is equal to 25. We do our factored form here, okay? And this is going to be x plus 2 squared. Now remember, this sign that's attached to the x and the y will tell you the sign that goes in the parentheses. So if this is positive, so is this. If this is negative, so is that. And this should be y minus 3 squared. So the center is the point negative 2, 3, and the radius is the square root, so it's 5. All right. And last but not least, our favorite topic of the year, arc length and areas of sectors. All right, I kind of looked this up a little bit. So the formula we were using was circumference, so it's 2 pi r times the angle over 360. And if we're doing radians, it's just, instead of doing angle over 360, it's over 2 pi, okay? So that's essentially our formula we're using. This is in degrees, this one's in radians. Now there's another way to do this, which is just using a proportion. You're basically just doing the arc length, right, over the entire arc of the whole circle, which is the circumference, is equal to the measure of the arc, which is also the measure of the central angle, right? So this is also the central angle over 360. And you can just cross multiply and solve. So we'll do one of each. You can kind of get the feel for it, see how you like it, and then we'll go from there. So take a look at the first one. We have this is 315 degrees. We're going to find the length of this arc right here. So we're going to do 315 over 360 times, and then it's 2 pi r, which here is 11. So if you take your calculator, All right. And we can do 315 over 360. Your calculator will automatically convert this to a fraction. It's 7 over 8. So it's 7 over 8 times 22 pi. And then we can just, now it says nearest tenth. So it's times 22, throw a pi in there, hit enter. And our nearest tenth is going to be 60.5. And this is in feet. Now, if we use our proportion, right, the arc length, we don't know. So that's going to be x over, and here it's going to be, right, 2 pi r, so 2 pi and 11. So this is 2 pi times 11 is equal to the central angle, which is 315 over 360. And then I just cross multiply and solve, and that's it. Okay? So it's 360x is equal to, and we can just multiply this stuff together. 315 times 2 times 11, we'll just do that. That's 6,930 pi, and we're going to divide that by 360. And then the x is just our answer. So times by pi divided by 360, and look at it's this guy right here, by the way. There's our 60.5. So that's it. Okay? So if you like using the proportion, it makes a little more sense, go with it. If this still works, because that's how we kind of learned it the first time, stick with it. It's your call, okay? Here the measure of the angle is given in radians, because it's the angles with a pi. So if you remember, we did angle over 2 pi times 2 pi r, and we just cancel out the 2 pi's. Okay, so it's the angle times r. That's it. So our angle is 3 pi over 2 times it by 16, and this is 3 pi times really 8 because these reduce down, and so this is just 24 pi. And by the way, we're going to need a calculator for that, right? And that's 75.4. All right. If you want to use the same idea, the arc length over circumference, which is 2 pi times 16, is equal to the arc, or the angle, which is 3 pi over 2, divided by 2 pi. Cross multiply, we get 2 pi times x, and we can do a few things here, right? 2 pi times 16 times 3 pi over 2. We're going to get this crazy decimal. And then this is how it's going to work out. It's actually got a pi squared in it, which is weird, right? It's 2 times 16 times 3 over 2, and then the 2 pi's give us pi squared. So if you'd rather, I think in this case, it kind of makes sense just to write down this and then divide by 2 pi here. Okay? So just answer divided by 2 pi. We'll do parentheses here. 2 pi. And there's our answer. Okay? Same thing. So it's your call. But that's essentially all that's going on. Okay, find the length of the radius to the nearest tenth. So if we use the formula, and this is where this kind of works out pretty okay when we're doing it too. But the formula here is going to be the angle over 360, right? It's degrees times 2 pi r. And then this is equal to the arc length, right? So I know it's the arc length because it's giving me the distance around. And then it's just 19.6 is equal to 130 over 360 times, and this is just 2 pi times, I don't know. So a couple things we can do. We can just divide by the fraction, right? Or multiply by the reciprocal. It's your call. So if we divide this by 130 over 360, then we're going to get something equal to 2 pi r. And then we just have to divide by 2 pi, and we'll have our answer. So that's kind of the idea here. All right. So I'm going to do 19.6 divided by, parentheses, 130, over 360. And you guys can use your fraction finder calculators here. And this is 54.27, right, and change, okay? If we want to try fraction, we can. It's this guy, so feel free to write it down if you like, all right? We'll go with the decimal, 54.2769230.8. Remember, we're not rounding yet. Divided by 2 pi. Just parentheses on there too. Not cosine though. We don't need any cosines. And we end up with this. And nearest tenth would be 8.6. Now, if we're using our proportion, right? The arc length is 19.6. The circumference is 2 pi r. The angle is 130 over 360. And I'm just going to solve for 2 pi r. That's it. So I do 19.6 times 360. Let's just get that new number. So this is 130 times 2 pi r. So really 130 times 2, right, is 260 pi r. And then we can do 19.6 times 360 is 70,056. And all I have to do here is divide by 260 pi. And r is equal to and there you go, same answer. Okay, so the proportion thing is kind of useful in this instance here, right? Find the length of the central angle. So once again, we're going to do the same thing. All right, we know if we use the proportion, it's the arc length 7.1 over 2 pi times 3.9 is equal to I don't know over 360, and then we're going to solve. Okay. So 360 times 7.1 is 2,556. And then 2 times 3.9 is 7.8 pi. And then times x. Divide by 7.8 pi. And we'll have our answer. And here we get 104.3. The other option, right, is to use our formula. Angle over 360 times 2 pi r is equal to the arc length. And then we would plug in. So 7.1 is equal to, I don't know, right, over 360 times 2 pi times 3.9. And same thing, it's going to get a little hard from here. So all this stuff flows to the top. We multiply by 360. We divide by 2.39. So I kind of like how this is working out. So give this a try when you guys are working on this today and see if this works. If you know how to do this way and you can keep doing it, go for it. Remember, when we multiply these together, this just goes right to the numerator. So this is 7.1 is equal to 2 pi x times 3.9, which remember we said was 7.8. So let's just put the 7.8 in here when we combine like terms, okay? Over 360. And then we're going to cross multiply. So 7.1 times 360, we already know from this, is 2,556 is equal to 7.8 pi x. And then I'm just dividing that out. Okay? And you can kind of see it's just kind of shortcuts this. All right, areas of sectors. So if you want to do the area of the sector, you're going to do the pi r squared times the angle over 360, or over 2 pi if it's radians. Keep in mind, you can also use the same idea, the same concept. The area of the sector over the area of the circle is equal to the angle over 360. Okay? Sector over circle, angle over 360. So it's kind of the same idea. Arc length over circumference, right? Angle over 360. Here you're doing area of the sector over the area of the circle, arc length over 360. So it's kind of a neat concept here. So angle LOM is area here is 2 pi. And then we know the length of NL right here is 6. So we know that this is then 3 centimeters. That's my radius. And we want to know what is the measure of angle M. So a couple things we're going to need. We need to figure out the measure of that angle, which is that arc, and then we can do half of it. Okay? So if we're doing this, we're going to use our formula, right? So we can go ahead and use this guy. So angle over 360 times pi r squared is equal to the area of the sector. And then we plug in. So 2 pi is equal to, I don't know, over 360 times pi times 3 squared. This floats to the top. So 2 pi is equal to 9 pi x over 360. And cross multiply, so 720 pi is equal to 9 pi times x. And then I just divide out. All right? And this should equal 80 when you're all said and done. Now, if this is 80, so is this, which means this angle is half. So angle N is equal to a half of 80, which is equal to 40 degrees. Now, if we bust it out with our formula, area of the sector, right, which is 2 pi over area of the circle, which is pi times 3 squared, or 9 pi, right, is equal to the angle over 360. That's it. I mean, that's all you're doing. Cross multiply. So 720 pi is equal to 9 pi x. We divide by 9 pi, and I think this way just makes a lot more sense. It's a lot easier. But once again, this is what we did. If you like it, stick with it, okay, as you're working along today, and you're going to get the same 80 degrees here for x. So try it. If you're having trouble with this, really go back and try this one, okay? See if it'll work for you. I think you might like it. Thanks for following through, guys. Enjoy your long weekend. Remember, part 2, 3, 4 from the exam, from the January 2018 exam is due. Make sure you're showing your work. All right, guys, enjoy.